Hello student, I hope all are you fine. Myself Mukesh Gangwar, your physics teacher from Brahmdar Saraswati Vidya Mandir Senior Secondary School, Bilaspur. Dear student, this video for the class 11 subject physics chapter number 4 laws of motion. This is the third part of this lesson. Dear student, we are today discuss about the conservation of linear momentum. Law of conservation of linear momentum. Law of conservation of linear momentum. Conservation of linear momentum. The law of conservation of momentum, the second and third law of motion lead to one of the most important and the fundamental principles of the physics called the law of conservation of linear momentum. It can be states the follows. It states when no external force act on the system of several interacting particles, the total linear momentum of the system is conserved. The total linear momentum is the vector sum of the linear momenta of the all particles of the system. Okay students, thus we can say that easily, if in the absence of any external force, the total linear momentum of the system is constant. Okay students. Hello dear student. Law of conservation of linear momentum. When no external force act on a system of several interacting particles, the total linear momentum of the system is conserved. The total linear momentum is the vector sum of the linear momenta of all particles of the system. Okay students, let a system of the consider an isolated system of n particles. Suppose n particles of masses m1, m2, m3 and so on mn, and are the moving velocities v1, v2, v3 and so on bn respectively. Then the total linear momentum of the system P is equal to m1 v1 plus m2 v2 plus m3 v3 and so on plus mn and bn. Okay students, then the p1 plus p2 plus p3 and so on pn. Okay, this is the total linear momentum. We know that F is equal to dp upon dt upon dt. If no force F is equal to 0, then dp upon rate of change of angular momentum is equal to 0. It means P is equal to constant. P is equal to constant. Then P1 plus P2 plus P3 and so on Pn is equal to constant. Okay students, thus in the absence of any external force, the total linear momentum of the system is constant. This is the law of conservation of linear momentum. This is the law of conservation of linear momentum. Okay students. Dear student, next topic, concurrent forces. Equilibrium of concurrent forces, the forcing The forces acting on the some point on a body are called the concurrent forces. When a number of forces act on a body at the same point and the net unbalanced force is 0, the body will continue in its state of rest or a uniform motion along the straight line and is said to be in equilibrium. Forces acting on the some points, forces acting on the same point, same points on a body is called are called concurrent forces. Okay students, when a number of forces acts on a body at the same points and the net unbalanced unbalanced force is 0. The body at the body will continue in its state of rest or of uniform moving यूनिफॉर्म मोशन ऐसे भी लिख सकते हैं, यूनिफॉर्म मोशन along a straight line, along a straight line and is said to be in equilibrium. Okay students, the forces acting on the same point on a body are called concurrent forces. When a number of force acts on a body at the same point and the net unbalanced force is 0, the body will continue in its state of rest or of uniform motion along a straight line and is said to be in equilibrium. Let three concurrent forces F1, F2, F3 acting on the same point O of a body. Okay students, three forces F1, F2 F3. F3 acting on the body at point O. By the parallelogram law, this is the perpendicular and this is the perpendicular. Okay. The resultant vector of F1 plus F2. Then resultant force of F1, F2 is equal to F1 plus F2. Okay. Then F2 is equal to F3 is equal to minus F1 plus F2. Then thus the force F1 plus F2 plus F3 will be 0. Okay. Then thus condition for the equilibrium of a number of forces acting on the body, some point is that the vector sum of the all these forces is equal to the 0. Okay students, बहुत सारे भी हो सकते हैं, F1, F2, F3, F4 and so on, Fn equal 0. सारे forces 0 होते हैं. Okay students, you are understanding the concurrent forces and equilibrium of concurrent forces. The next topic, friction. Friction, whenever a body moves or tends to move over the surface of another body, a force comes into play which acts parallel to the surface of connected and oppose the relative motion. This opposition force is called the friction. This opposition force of friction. Okay students, whenever a body moves or tends to move over the surface of another body a force comes into play which acts parallel to the surface of contact and opposes the relative motion. This opposition force opposing force, this opposing force is called friction, Okay students, this opposition force is called the friction force. Whenever a body moves or tends to move over the surface of another body, a comes force comes into the play which acts parallel to the surface of contact and oppose the relative motion. This opposing force is called the friction. जब कोई बॉडी किसी बॉडी पर मूव करती है, टेंड करती है, तो इनके जो सरफेस ऑफ कांटेक्ट है, इसके बीच में एक फोर्स वर्क करता है. क्या वर्क करता है? फोर्स वर्क करता है. और जो फोर्स वर्क करता है वो इस बॉडी की मूव का अपोजिशन करता है, मूविंग कंडीशन का अपोजिशन करता है. और दिस opposing force is called the frictional force. This opposing force is called the frictional force. Okay. Next, the type of friction. Number 1, static friction. Static friction, the force of friction which comes into play between two bodies before one body actually starts moving over the other is called the static friction. Okay, the force of friction comes the force of friction which comes into play between between two bodies before one body actually starts moving. It starts moving over the other body, is called static friction. Is called a static friction. It is denoted by Fs. The force of friction which comes into the play between two bodies before one body actually start moving over the other is called the static friction. जब कोई बॉडी किसी बॉडी पर मूव करना स्टार्ट करती है, तो जैसे ही मूव करना स्टार्ट करती है उससे पहले तक उसके बॉडी में लगने वाले फ्रिक्शन को हम स्टैटिक फ्रिक्शन कहते हैं. ओके स्टूडेंट्स, नंबर 2, लिमिटिंग फ्रिक्शन. Limiting friction. The maximum force of static friction. The maximum force of static friction which comes into play into play, which comes into play when a body just start motion over motion over the other surface, over the another surface, is called, ओके स्टूडेंट, इस तरह से भी हम जस्ट स्टार्ट ओवर द सरफेस अनदर बॉडी इज कॉल्ड limiting fraction, The maximum force of static friction which comes into play when a body just start motion over the another surface of the body is called the limiting fraction. Okay student, is called the limiting fraction. Fs is denoted by Fs because its maximum value of the static friction. It is also denoted by Fs, then Fs is less than Fs is maximum. Okay students. Next point, kinetic friction. The force of friction which comes into play when a body in a state of steady motion, is in a state of steady motion. Steady motion over the surface of another body is called the kinetic or dynamic fraction. It is denoted by Fk. Okay students, it is denoted by Fk. The force of friction which comes into play when a body is in a state of steady motion over the surface of another body is called the kinetic or dynamic fraction. It is denoted by Fk. जब कोई बॉडी किसी दूसरी बॉडी के सरफेस पर स्टेडी मोशन करती है तो उसके बिटवीन में, उसके कॉन्टैक्ट ऑफ फोर्स के बिटवीन, सरफेस ऑफ कॉन्टैक्ट के बिटवीन में जो फोर्स वर्क करता है उसी को हम काइनेटिक फ्रैक्शन कहते हैं। सो डियर स्टूडेंट, आई होप यू आर अंडरस्टैंडिंग द fraction of the static fraction, limiting fraction and the kinetic fraction.